Welcome back, guys. Today what I wanted to talk to you about is a little something I learned over the weekend about the usage of power between using the AC inverter and your 12 volt electronics. And what I'm talking about is, if you remember in a previous video last week, we wired up the van, we hooked up all the 12 volt, and we got to the point of the Dometic refrigerator, and I got a little hesitant on cutting the 12 volt power plug for the refrigerator because I wasn't sure which one was positive and which one was negative. And it had been a long day. You might still hear, but I've been battling a pretty bad cold all week. And I just said, you know what the heck? I have an inverter on this Goal Zero battery. I'm going to start running the fridge off of the 120 and turn on the inverter and just be done with it. And that worked, but what I found was it was an enormous drain on the battery. So one of the things I started doing is I got on the internet and I started looking for rewiring taking the 12 volt cigarette lighter power adapter for the Dometic refrigerator. I have a Dometic CFX50, and cutting that and wiring it into my 12 volt system here. And there was just a lot of questions I found online. I was really surprised that there wasn't just some examples. So I thought, you know what, let me muddle my way through this, and we'll post it online. So let me show you some of what I'm talking about, and we'll kind of look at some of the power voltages, or some of the power ratings, what it's using on inverter, what it's using on 12 volt, and I'll show you the adapter from the Dometic refrigerator and kind of show you how we figured out which one was positive, which one was negative, and hopefully it helps somebody out there down the road. Okay, let's take a look. So if you recall from a previous video, you'll remember we have the Goal Zero Yeti 1400 battery. It has 105 ampere hours of life to it, and it has a built-in inverter to it. And so we're using this inverter here for any of our 120 runs, and one of these runs to the driver's side of the van, and we'll use that for maybe blenders and so forth. And we have one that runs to the passenger side of the van. These are just big extension, heavy-duty extension cords from Lowe's, and they'll be what supplies that power. But with the refrigerator, we decided, as I said, I kind of got lazy, I guess, and I said, let me just use the inverter for it. But what I realized is what used to take a week to drain this battery, literally in a day and a half drained the battery using the inverter. And it was just something that really shocked me. I knew it would be more power, but I didn't know it would be that much. So let's take a look at what those power differences are. So you notice right now my battery is at 85%, and currently I'm at 0.1 amps that are being drawn from the battery. If I click over, wrong button. If I click over units here, or 1 watt is currently being drawn from the battery right now. But interestingly enough, if I turn on this inverter, which uses I do have one of these cords plugged into the Dometic refrigerator. If I turn on the inverter, what starts to happen is you'll notice that outputting now, I've just gone from 1 watt, I'm at 7 watts now, or I'm at 0.6 amps. So that's an extra half an amp that's running continuously 24 hours on this battery, a drain, a half an amp. And it might not sound like a lot, but when you take that over a 24-hour period, that's a lot more. And when the refrigerator kicks on, because it's using the inverter, it's actually using more current or more watts, depending on what units you're looking at, when it's running over this inverter, that are being drawn from the battery to run the refrigerator, than if it was simply running off of the 12 volt. So let's take a look at what some of those differences are. So right now I've got the inverter turned on. It's saying it's drawing 0.6 amps right now on the screen, but when we started it was also drawing 0.1 amp. So I'm going to say it's drawing a half an amp just because the inverter is currently turned on and used. So what I'm going to do is I'm going to go over to the refrigerator. I'm going to plug I'm going to turn it over to AC current, and I'm going to open up the lid to the refrigerator to get it to turn on, and we'll see what that reading is. And then we'll do the same thing on the 12 volt side and see what the difference is. So we can see that, the biggest reason for trying to get everything you can onto 12 volt circuits versus your AC current. So just with the inverter running, we're running at a half an amp right now. Okay, so what I've done is I've taken off the 12 volt off the fridge, and I have it running on the 120 side, and I've opened up the lid for the refrigerator. So let's just give it a second here until the fridge turns on, which will just be a minute, and we'll see what this output goes to. So I'm at a half an amp of draw, or I'm currently drawing 7 watts, and that's just the inverter running. That's the refrigerator hasn't clicked on yet, but we'll see what that goes to in just a second. Okay, so the fridge just kicked on. I'm running on 120, not 12 volt now, and I'm outputting 75 watts for the refrigerator to be running, or 6.4, I'll say 6.3 amps. Or yeah, I'll say 6.2 amps because it seems to be fluctuating a little bit. So on the 120 side, I'm running at 6.2 amps, a little more than 6 amps. And I'm outputting about 70 watts. That's running using the 120. Because you have to remember, I'm actually adding watts because of the inverter running to allow that to be converted over and used with the 12 volt DC battery. So that's what we get on the 120 side. So let's switch it all back off and go over to the 12 volt side and see what we have there. Okay, so we've moved over to the 12 volt side now of the refrigerator, and I'm going to shut the inverter down on the Goal Zero battery here. You'll notice we're drawing a half an amp, or let me switch over to watts. I'm drawing 6 watts just with the inverter running. Nothing else is operating. It's just simply the inverter within the battery is drawing 6 watts just to manage itself. So if I shut that inverter off, now I've just dropped down to 1 watt. So that 1 watt will be the battery itself, just the general maintenance of itself, managing the power, because I do still have the 12 volt here plugged in. So that will create a little bit of a leakage, if you will, just to manage that. So let's get the refrigerator to kick on the 12 volt side, and we'll see what we get there. Okay, so now I've got the inverter shut off. I now have the refrigerator, it just kicked on running on 12 volt power, and you'll notice I'm at 60 watts being drawn for using it over the 12 volt side. If I switch that over to amps, I'm using 5.1 amps. So it's actually a smaller draw using the 12 volt side. Remember though, we don't have the inverter in operation. The inverter is now turned off, so there's none of that is involved in this because it's on the 12 volt side. And you can see as the fridge runs, after it kicks on, it starts to drop down. So now we're at 4.8 amps. If I kick over to watts, I'm at 56 watts, which is definitely smaller than of a draw that we just were on the 120 side. Alright, so I brought this inside because the sun is beating down on me outside as I'm peering in through the back, and I wanted to kind of show you the outlet for the refrigerator itself. So the 12 volt connector for the refrigerator is just this end. It has a positive and negative end on it, and on this end I'm now wired in temporarily to my to the wiring I put into the van here, the red and black wiring. But the big question I saw online, and I had initially, is so which one of the wires of the 2 wires that are this is one of these little double wires going down. So which one's positive, which one's negative? So on the cigarette, on the male adapter, the cigarette lighter adapter on the fridge, when you have these adapters, your outside is always your negative, and the end here is always your positive. And that's great to know here, but the problem you run into is I need to know what it is at the wire side. Well, if you unscrew the adapter on the Dometic fridge and unplug it, they actually have two little leads here, and at the end, right in the plastic, it shows you positive, negative. So all things being considered, let's say Dometic did everything they were supposed to do when they made this connector, or the makers that made the connector and sold it to Dometic, however that worked. You know, however these two connectors go in, and wherever it connects up to the wire goes in, should go in straight. And then looking at this, it's, you know, positive and negative on this side. I didn't necessarily want to trust that once these wires got up in here, they weren't twisted. So one of the things I did was take a simple ohm meter that you can get at any hardware store. This one I think was about 30 bucks, and check the circuit on this connector. And basically what you do is you just set it to ohms, and basically what I did is, before I cut this wire, I kind of pulled it apart a little bit, about 3 inches, and just bared out a little piece of wire on each side. I kind of dug into the insulation, and then I took one lead and put it on that wire itself, and then the other lead and put it on the connector that, you know, said positive or negative. And with the ohm meter, if it stays a 1, you don't have a connection. If it goes to 0, you've found your right wire. You're connected through there. So you know that whatever one this one says, if it went to 0 on the ohm meter, you know this one is whatever this says over here. So the reason this is important is, once you cut this wire, and I saw this from a lot of people online when I originally went online to see, you know, what was the wiring of the 12-volt side of the Dometic fridge. So I could just cut the cable, go in, strip it out, you know, take my red and black wires that I had run through the van a couple of weeks ago, put the red to the positive, the black to the negative. I had already last week hooked this fridge run up on the 12-volt fuse block. I just didn't know at the time which one of these was positive, negative. But simply using that ohm meter and finding out which one, and then marking the one positive, I just wrapped a piece of tape around it, took a pen and put a plus sign on it. So I always know going forward, even if I have to rewire it down the road, I know which side's positive, which one's negative. And at that point then, simply taking the end of the wire here with the refrigerator, cutting this piece off, and then taking the one that's positive, putting it into my red, and the one that's negative, putting it into my black, and going from there. And I used a 20 amp fuse in the fuse blocks for this particular run. Now, the one thing that's key on the 12-volt side, I've seen a lot online with the Dometic refrigerators, is on the 12-volt side, it really requires a really good circuit. And what I mean by that is, you know, this wire here, when you break them apart, these are probably about, I'm going to say, maybe an 18 gauge, 14 gauge wire. So you certainly don't want to take that gauge wire and run that long distances, because you're going to have a loss. The longer that cable is, the more loss you're going to create in the line. So if you recall from a previous video, I ran 12 gauge wire, which is a thicker wire, through the entire van. So hooking up a 12, the key to that is you don't want to run the same or smaller gauge wire, and by smaller means is a higher number. You don't want to run a smaller gauge wire that distance, because you're going to get a loss and your fridge isn't going to run as efficiently. So hooking this smaller gauge wire up to my 12 gauge wire, and I say temporarily because I just put wire nuts on there, but when I make it permanent, I'm actually going to solder those ends, shrink wrap it, so I get a good, I don't have any loss at those connections, so I have a good solid connection. And then taking the meter, like I took my meter from the 12-volt side and saw how many volts I was getting here on a 12-volt side, and checking the length, and I was getting no loss down the line using that method. So key points are, from this video. Number one, try to go 12 volt. You're gonna save your battery's life and extend your adventure a little bit longer. Key two, make sure you check with an ohm meter on before you cut these wires, which one's positive, which one's negative. Make your life a whole lot easier. You certainly don't want to wire it backwards, because you could very potentially blow a fuse, smoke a circuit, etc. And point three, when you're hooking it up to 12 volt, make sure you're putting it to a solid, a heavier gauge wire, or at minimum the same gauge wire, and be careful of the length of distance you're running that run, because you're going to get a loss over that line, and you don't want the fridge to run less efficiently. As it turns out, using the 12 gauge wire put onto what this looks like I said, probably a 16 gauge wire maybe on the 12 volt wire that came with the refrigerator, I'm getting no loss. The fridge runs very efficiently, and the difference when I was running on an inverter, if I charged the battery up to 100%, ran this refrigerator only, it took maybe a day and a half to run that battery down to the point of, say, 65%. When I run this refrigerator on a 12 volt circuit, not using an inverter, this refrigerator, I can charge it up to 100% on a Sunday, and this thing will run till Thursday or Friday of that week before it hits down into the 70% to 65% range. So the length of time that I'm getting out of that battery life is far longer over the 12 volt side. So point to remember, overall point to remember from this is anything you can put on the 12 volt side, put on the 12 volt side. Don't get lazy and plug things into your 120 lines, because you're just going to utilize power, and you may have that power to use in your van build, but you have to remember, like in the summers and so forth, those inverters and that equipment is going to create heat. And right now we're kind of sitting in the van. I do have the max air fan on exhaust, so there's a little bit of breeze in here, but it's a hot day right now. And the last thing I would want to be doing is creating more heat in this space if I didn't have to. So until next time, this is Ken. I got to get out of here and get some air because it's really hot in here. Peace. Like the video, subscribe to the channel if you like the content we're putting out. Consider sharing the video. And until next time, we'll see you.